Awesome. So I will get started here. We'll start a little slowly for other people to join. Welcome from The Hague. Thanks for joining in the evening. And yeah, so I just want to introduce myself. I'm Lisa Taliaferri. I lead the developer enablement team at Chainguard. And I'm going to be going through a cool demo about our Python image. And I will share my screen. Awesome. So if you're here for the Learning Lab about Python, you're in the right place. We're going to be talking about the Chainguard container image on Python. This is our fearless mascot, Linky, and Linky will be part of this demonstration. So I hope you enjoy octopuses. This is a little bit about me. As I mentioned, I lead the developer enablement team at Chainguard. My previous startup experience, if you're interested, is at SourceGraph and DigitalOcean. I'm also a recovering academic if you care about academic CVs. And then you could find me on Blue Sky today. And this is not actually a picture of me, although I feel a lot of affinity with Lisa Simpson. This is me. So the agenda today is we're going to talk a little bit about CVEs. We're going to talk a little bit about Chainguard images. We're actually going to do 2 Python apps, and we're going to migrate to Chainguard, and we're going to talk about multi-stage builds and a little bit about minimal containers. So prerequisites, we're going to use, this is all going to be a command line demonstration. So you could use VS Code or whatever you would like. I'm going to demo with Nano because I think that one is easy to keep it all in the command line. And it's easy for me. Hope it's easy enough for you too, if you'd like to follow along. We'll also have a recording of this, and we also have a full written tutorial of this. So if you don't want to follow along right now, you could go through this tutorial later on, and I will put a link in the chat right here. So this is this link that I shared in the chat is very similar to what we're going to be going through today. I think I need to update one of the items in the requirements.txt file of that tutorial, but otherwise we're good. And then pulling something from my colleague Patrick Smith, he has a real hatred of CVEs, so I also hope that everybody here hates CVEs too. So CVEs, it stands for Common Vulnerabilities and Errors. They're known vulnerabilities. We have a whole list of CVEs that are available to look at on our Chainguard Images security advisories. So basically, CVEs are here to kind of hurt your app. We don't want to have them. Common vulnerabilities and exposures, not errors, I think. So these have the potential to create an attack surface for bad actors to kind of get into your app, to expose your app to problems. And we just really don't like CVEs very much at Chainguard. We want to make your app have as few CVEs as possible. We want to lower the potential attack surface so that you're not kind of setting your own software and setting your users up for that kind of risk. So the issue that we see is that, you know, you're coding, your team is coding, you could do like everything right, but as you know, like you're going to be pulling probably from open source. And like, you know, I consider myself to be an open source person. I love open source. But there's going to be some CVEs in open source, and it's just something that happens. A lot of CVEs are not necessarily bad, but the issue is that the more CVEs you have, the harder it's going to be to like kind of determine which CVEs are actually bad and which are not. So what happens is like you're looking at CVEs, you see a lot of CVEs in like a container image, for example, and you don't know which ones are actually going to impact you, which are actually going to impact your users. Like it could be bad for business, it could be bad for like identity, it could be bad for lots of different things. So you're just taking this risk when when you have this large potential like attack surface. So what Chainguard hopes to do is to guard you from CVEs by decreasing that attack surface as much as possible. So Chainguard, what we're trying to do is be the safe source for open source. We're trying to start left and to raise the waterline. These are some of the open source projects that people at Chainguard work with. I shout out to the SigStore team. So Chainguard images, what do we kind of provide here? We provide low or zero CVEs. We build our container images daily for extra freshness. These are minimal container images. So they come from like the kind of thinking behind distro lists, if you're familiar with that. So like we built our own operating system that's container OS, which is the Wolfie OS. And this really minimizes the container images so that you only have in your container image what you want. They also come with SVOM, salsa, and provenance. So if you look, and this is yesterday, if you look at some of our CVE visualizations, which we have both on Chainguard Academy right now and on the images.chainguard.dev, you could find the CVE visualizations. If you look at the Python upstream image, in this case, this is the one that we're pulling from the Docker Python image. We see that there's quite a lot of CVEs there. So as of yesterday, there were 170 total CVEs. The issue is that there's like 6 critical CVEs in there, and this is nothing. I love Python. This is not something that's we're not casting aspersions against Python, but this is just something that happens when you have a lot of software and you're working through lots of CVs and trying to mitigate them. Yeah, and as of yesterday, the Chainguard Python latest image had 0 CVs. This has a little bit of chutzpah, but one of the memes that I designed early on at Chainguard is this: software security is hard, changed my mind. Our hope is that software security is not hard. Whether or not that's true, there's some things that we have to keep in mind, and that's why we're here to talk about that today. Right, so what Chainguard does, we want to strip dependencies, we want to keep it fresh, we want to patch, we want to issue advisories, and we want you to have 0 CVEs. Of course, sometimes there's going to be a minimal amount of CVEs, and we'll talk about that too. So this is actually, I did not update this slide, but you could follow this also, great slide. We're going to follow this this tutorial, and I have a repo which I'll share with you too. So the tutorial again is this, but I'm going to stop this share and I'm going to move to the command line in one moment. How does that look? I can make it a little bit bigger. Maybe the text doesn't get bigger. Okay. So I hope that's okay to read. So I'm in this Learning Labs directory. I recommend that if you want to follow along to choose a choose a temp directory, whichever whatever kind of directory you use to do demos and kind of test things. Let me just clear my windows up a little bit so I don't see myself so much. Okay, so what I'm going to do first is so we're going to do 2 quick CLI demos. I'm going to do one demo that is minimal, kind of your single build Docker file. We're going to do it first with the Python, the upstream Python, the Docker Python, and then second with the Chainguard image. We're going to do some gripe scanning, and that will be the first one. And then the second demo, I will take you through a multi-stage build. Okay, so first I want to create our own directory for this. So this little app is it generates octopus facts, and I want to say that if you would like to contribute octopus facts to this app, I will share the GitHub repo with you because it could use some more octopus facts, if you know what I mean. So we enjoy octopuses here at Chainguard, and that is because of our mascot, Linky. And I want to tell you a little story about Linky. So the reason why the octopus is the mascot of Chainguard is because there was this story of an octopus going from one aquarium tank to another to eat the other fish. So this octopus is like a CVE, but we actually love Linky, but it's just, you never know. You never know where these attacks are going to come from. So this is the text file that I curled just now, so you don't have to copy that. And I also certainly did not copy that, did not write that out. So we're just going to take a look at this real quick. So this is this facts.txt file. So the first few lines, right, is the oldest known octopus fossil belongs to an animal that lived 296 million years ago. Octopuses have 3 hearts, and the plural of octopus is octopuses. And I'm willing to fight grammatical nerds about this because octopus is not a Latin word, so it wouldn't be octopi. It is actually Greek, so it would be octopodes. But since it's in English, it uses the English standard. So you came for the container images, and you get octopus facts. So I just made a little Python programming environment, and you could do that, or since this is a demo, it's not totally necessary, but I like to do that. So we're going to make a little main.py Python file. So in the tutorial, we have lots of doc strings for you that explains everything that's happening, but I'll just try to explain it in real time. So we are importing the random dependency here. So def random line text. So we're going to open this file, right? We're going to read it. And I'm probably going to make a typo. And we're going to read the lines. So we want to, right, there's that text file. And we want to have Python kind of read this text file line by line. We wanted to randomly choose a line, and we are going to we wanted to print out that random line for us. Here's our names. Oops. Let's see if that works. And then we run Python. Oops. I highly expect there to be a typo. Oh, it worked though. Okay, so octopus is about 90% muscle. Very impressive. You don't want to compete with an octopus in the gym. So deactivate, we could deactivate this because now we're going to move to our Docker file. So right now, just to take a look, right, we have in this file, we have our programming environment. In this directory, we have our programming environment, we have main.py, and we have facts.txt. So now we're going to create our Docker file. So we'll pull in this syntax line to make sure everything is looking good, and then we're going to pull from Python 3, which we'll be pulling from Docker. We want our working directory to be at ActiveFacts. We want to copy main.py and facts.txt. And then we're going to pull from Python. Oops. Typing live is hard. Okay, so we're copying the main.py, facts.txt, and hope for the best here. And then we're going to do a Docker build. Let me see. I noticed that it's not, the whole line isn't showing up for y'all. So I could also copy the commands into the chat if that is helpful. So we're going to pull down, we're going to build and pull down, and we're going to call it basic ActiveFacts because this one is the upstream Python, and then we're going to show it with the Chainguard Python. Okay. Oh gosh. What do I do with me? I don't want to copy this. All right, so now we have it. And if I am running on a Mac, as you could probably notice, so if you are running on a Mac, just make sure you have your Docker running. And then we're going to run this to just see that it's working. All right, so robotic engineering has benefited from imitating the soft, flexible, strong arms of octopuses. Very exciting octopus fact. So here's that command if you need it. And then, so what we're going to do now is we have this, it's like obviously a pretty small app, right? It's we're taking in a text file, it's printing out something on the command line. It's very minimal kind of app, right? And we're going to use Gripe to scan for CVEs. So Gripe is something that we use internally. Chainguard also will work with other scanners, and we have a lot of that information documented on Chainguard Academy. If you would like to learn more about scanners, I think this is kind of how a lot of we have it baked into our CI/CD so that we could check our own stuff. But we like to use Gripe in particular. I think it's like a pretty lightweight and nice scanner. But you see it's taking quite a bit of time. And then when after everything gets spit out, we see that there's, and I apologize about this, it being like text and not the biggest text size for you, font size. But as you see, there's quite a lot of CVEs. We see some of them are negligible. We have some high, some medium. Gosh, it takes a long time to scroll all the way up to the top here. Okay. So if we go back to the top, then we see, right, that scan for vulnerabilities. There's a lot of vulnerability matches. By severity, there are 7 critical, 116 high, 314 medium, 51 low, 612 negligible. 75 have been fixed. So a lot have been not fixed and some have been ignored. Cool. Okay, thanks Brian for letting me know about the text. It's hard for me to see from my view, but hopefully it's good for all of you. All right, so this is our the Python 3, just pulling Python 3 and not like specifying. So if we go back to that Docker file, I'm gonna just go through and change this line. So instead of from Python 3, we're gonna take it down from Chainguard. And I could copy this into the chat too. So this is the only thing I'm changing. And then we will go through this again with the Docker build. And then we're going to call this CG Octofacts instead, just to have, so we know it's different. Right. And then if we want, we could run it again and make sure everything's working right. See, there's a problem here. Let's see what happened. I will just make sure this is right. Yes, okay, sorry. I changed this. Yes, this is what I missed. I missed the entry point. Sorry about that. So this is the full thing, and it's because I tried to just type it live. So I built it again. So let's run it now. Okay. So octopuses have strong eyesight and are suspected of being able to see color in a very different way than humans. I think something like the mantis shrimp also has lots of cones on their eyes. Cool. So now we know that it's working. So just to show you that Docker file again, I'm sorry about that. So we changed this line, the from CGR dev, and then we changed this line. So let me copy and paste that into here too. Cool. So now let's run the grape on this. Cool. All right. So here we see that there is one CV. So this gives us a chance to look at this. So this is one CVE. So as I showed you, like as of yesterday, there were 0 CVEs. Today we see there's one CVE, and as I mentioned, we build nightly. So it's actually an interesting thing. So let me show you a different window. So here, if you go to images.chainguard.dev, this is the page I'm showing you now. And if we search for Python, we can take a look. So, right, what I'm showing you right now is this Chainguard Python latest image. And this is our wonderful directory, which shows you a lot of information about Chainguard images. So this is the advisories, and this will give you real-time information about the advisories. So if you compare like these CVEs to those CVEs that we got from the initial Greg report for the other Python image, where we just pulled down Python 3, you'll see that like these CVEs are that were in the other image are like how they're being mitigated in real time by Chainguard. So this CV 2024-3220 is under investigation as of 10 hours ago. So like, you know, give them 24 hours and take another look at this. So Chainguard has detected a potential vulnerability match for this package and is investigating to determine remediation. So there's also, and when I'm done talking, I'll try to share one of the blog posts that we have where sometimes we'll catch CVs before they're even noticed by by upstream software. It's just something like, because we really, really hate CVs here. So we want to make sure that we get rid of CVs. But as you know, this is like an ongoing process. And we will continue to combat CVEs. But this just kind of shows you a little bit about how things are made. And let's go back to the other screen. Okay, cool. So I just, since I messed up that Docker file, let me just show it to you one more time. So we have cgr.dev chainguard Python latest. The working directory is octofacts. We copied main.py facts.txt and then our entry point. And I will share this with you, the tutorial again at the end. Awesome. So we do have one CV in this image, but compared to the other, it's like quite a big difference. And we will remediate the CV, I promise. So our next little demo is going to be a multi-stage build, and like in the interest of time, I won't show you the difference between upstream. So this one was very nice where we didn't have to like do a pip install and everything. So this next one we are going to do a pip install, and that's why we're going to use a multi-stage build. Okay. So we're going to make another directory. So I'm in this Learning Labs directory, but you know, make this wherever you want. And this one we're calling Linky again. So you know, the octopus name is very important. And then we're going to do our programming environment, and then we're going to activate that. And then we're going to create a requirements.txt file. Okay. So before this session, I learned that the version of setup tools that is on the tutorial I shared with you has a CVE in it. So I am updating it now, and I will update it. I will open up pull requests against that tutorial, but when I'm done with this session. But this is hopefully I copied and pasted this correctly. But this is, we're using setup tool 70 and Climate, and this is not a robust app, but I think it's a fun app. So we're going to create linky.py, and then Climate, which will show, and I'm not sure if I'm pronouncing it correctly, but this will let us show a graphic on the command line, which is very cool. And I was inspired to make this little demo based on the ChainCTL, which is our tool for accessing Chainguard, our CLI tool. So just take this. Okay, so Linky, I probably should have curled this down first, but I'll curl the PNG in a second. So we are going to use this linky.png, and we're going to convert it. And Okay, and then we're gonna, I should have done this first because the order of operations, but this is the file. And I will paste this into our chat. And then we will, yes, the next step is we have to install those requirements, right? You know, I keep updating to it's fine. Okay. Okay, and then Python linky.py. Oh gosh, see, there's the problem. I will, here, I will copy my little program with the beautiful dog strings that I care very much about. So I don't know, I think I did something wrong in the if statement at the bottom, sorry. So this is available on that tutorial that I mentioned. The setup tools will need to be updated so you don't have a CV, but if you run it like as we're in today, you will get an error with, okay, here we go. You'll get an error, you'll get a CV with that setup tools. So here is our wonderful Linky octopus. It is very large. If you care about doing something like this with a CLI project that you're working on, you may want to play with this tool a little bit more. But for our purposes, we want a large Linky today. Okay, so let's just deactivate this. We're done with the programming environment. So okay, we're gonna make a Docker file. Okay, so this is going to be a multi-stage Docker file. And this is important because we have, if we look back, to what I showed you before, the Python, sorry, the Windows, I know you all understand about the pain of Windows. Not, well, those Windows too. But if we go back to this Python director, this Python image in the directory, right? So I showed you the advisories quickly, but this is Python in the Chainguard images directory, and we have these two versions which are available in the free tier for you to use today. And I showed you so far the latest, but now I'm going to show you the latest.dev. So if you toggle over this, a very helpful tooltip, this image contains additional software to help in developing and debugging applications, such as a shell and a package manager. So this latest does not have those things, and that is important for us because we don't want to have, like, we want to minimize your potential attack surface, right? So what we get with a multi-stage build, which I think is really cool, is that we will pull in this latest dev so that we could do that pip install, bring in the packages, right? So random, which I showed before, is part of like is native in Python, right? It was incorporated in, but this other thing, climate CLI image, I guess is what you would call it. That one is something that you have to pip install in. So in order to avail ourselves of pip install, we need to use the latest -dev tagged image, and that will let us bring that in. And if you're interested in learning more, like for each image, we have this overview that gives you information about the image at hand. You could also go onto Chainguard Academy to learn more, and this is the link that I shared with you, which is the getting started with the Python Chainguard image. And then there's information about debugging gestureless images, which the dev variant can help you with debugging as well. So let's go back to the terminal. All right, we are in this blank Docker file today. And All right, so what we are going to do is we are going to start a new build stage based on the Python latest dev image, and we're going to call it builder. And then we're going to create a new virtual environment that will cleanly hold the application's dependencies, right? So we only want to bring in the dependencies that we need. Of course, with something like a CLI graphic, it is, decide for yourself if including this package is like important for your work. We're going to copy the requirements.txt from the current directory to the linky location in the container. We're going to run pip install so that we could get those requirements in to install dependencies. We're going to start a new build stage based on that Python latest without that dev tag. And then we will copy those dependencies over and then set up the application as the entry point for this image. Okay. All right. So let's get to it here. So hopefully we don't make typos, but it's very possible. Okay, so this is this builder, which I mentioned. So we're bringing in this latest dev as the builder, and the dev, again, will let us do pip install at the very least. I'm I will actually copy these because, right, so we're doing the linky event. The work directory is linky. I'm going to run Python M, then linky. And then we're going to copy requirements. Okay, and then we're going to run pip install. Okay, so that's our builder part. So that's the dev, right? So this allows us to do the pip install. And then we're going to do Python latest. Working directory, Slinky. And this is our python.png, the image. Okay, so from that builder, we are going to bring this in and then enter code. All right. Copy. Device code. Oops. Yes. Okay, so copy requirements.txt. Yes, thank you for pointing that out. And hopefully there's no other errors. But yes, kind of walking through it again, like we're taking the latest dev as builder. We want to pip install those requirements, that requirements text file. Then we want to bring that over into the latest, the just latest tag. So this will be a multi-stage build. All right. Hopefully it works. So Docker build full linky. All right. Docker run. Oh gosh. Here we go. So here is our linky. So I know it's like a big Docker file for this little demo, but I think that these like multi-stage builds are really cool, and I think that a lot of the time, right, the latest dev will kind of get you most of the way there to like your no CVEs. Even when you're pip installing these things, but I think that this is just nice to kind of do this multi-stage build, and I think it kind of shows like what is the value proposition for having Chainguard images. So here we get, I just run gripe again. It doesn't take very long with the Chainguard images, and we see again that there's that CVE that I mentioned before. Awesome. I am all set here. I was wondering, Docker images linking to show size. Okay. Cool. So this is, just to show the size of the linking, which I guess I could have talked about that a little bit more, but the size, if we go back, what's this object class? You could go back and look at those two. Was it basic object class? Yeah, so oops. I guess I want to move directories anyway. Yeah, I mean, I think so. This one, right, has 98.1 megabytes. It does have that image in there, although who knows how big that image is offhand. I don't know. And then this, if we look at that Python, the one that we just pulled, we have a 1.02 gigabyte image versus a 60.9 megabyte image. So you see, like the other thing that's cool about this is about Chainguard images is that but not only are we reducing the attack surface, we're reducing the size by quite a lot, which could be cool for everybody. Awesome. I could go back to the slide deck. All right. So what did we do? First we did the latest, then we did latest dev, and latest with a multi-stage build. And then for debugging distro lists, I could share with you a tutorial, but here are some pointers to start with. Like there's latest dev variants that you could use to debug. There is the Docker debug, C debug, and ephemeral containers. And we do have some guidance about this. So we have a troubleshooting section of Chainguard Academy, but here's a quick tutorial if you're interested. And that's all for me. If anybody has any questions, Chainguard team will be here for a few more minutes, but thanks so much for coming. Yeah, so I have not actually tested. So the question is, any tips on data science libraries with pip utilizing the Chainguard Python image? So I would actually like to play with this, but I haven't personally yet. But I wanted to share with you, we do have the AI images, and we did do a learning lab about it. So let me just grab that for you. We do have some AI images, which is probably potentially more than what you need for, if you want to do like pandas or something. But I will share with you the AI one because I think it's quite good. And my colleague Patrick led this, which he's great at doing learning labs, I would say. So this is the video about the AI images. I think, yeah, for NumPy and Pandas, I think the AI images may be overkill, but like that will have what you need in there. But otherwise, and I'll stop sharing this GIF. But otherwise, yeah, I will get back to you, and I think we should do a tutorial or something about pandas, because pandas is something that I also love. Yes, I think we will have some more interesting things about wheel dependencies too soon. And let me see, I think we do have a PyTorch tutorial as well. Um, so these are like, yeah, testing access. It is not it is a, I showed you very like kind of minimal demo, but this, the PyTorch demo is more serious, I will say. Like as somebody who has gone through this tutorial, it takes more time for sure. But the learning lab is very good. Thanks, Adrian. Thank you, Brian. Thanks, Erica. If there's no other questions, I think we could close it off. If you have any final thoughts or concerns, you could open an issue against the Chainguard Chainguard Academy repo, and if you have, I mean, feel free to open a blank issue if you just want to kind of chat, and we're happy to talk with you there. Awesome. Thanks, everybody.